in this particular video, we will be discussing different types of operations that can be performed on sets. Okay, so the first such operation is intersection of two sets. Let A and B be two sets. The set of all elements that are common to A as well as B is called intersection of set A and B. So, if we take two sets and if we form a set of common elements from A and B, means those elements who are common to A as well as B, then that new set we will call is intersection of A and B, and we denoted as A intersection B. And if we want to denote the set using the set builder form, we can write it as A intersection B contains all such X such that X belongs to A and X belongs to B. If X is in A as well as B, then X is in A intersection B. So this is the definition of intersection of two sets. That means set of common elements from both the sets will form intersection of that particular two sets. Now we will take two examples so we have a clear idea about it. Okay. Consider set A is equal to 1, 2, 3, 4 and 5. Set B is equal to 1, 3, 5, 7, 9. Okay, so what will be A intersection B? That means we have to find those elements which are in A as well as in B. So which is the first element which is in A as well as B? It is 3. 3 are. And then do we have any other element? 5. 5 is also here. There are no other common, and 1 is also there. Oh, I'm sorry. First one is not 3. Okay, I can write it in the end too. Order is not important. So 1 is there, 3 is there and 5 is there. So there are 3 elements which are common to A as well as B. Now let's see how we will represent it using a Venn diagram. Okay. So just think that this is set A. I will first make both the, and now this is set B. Now we need it slightly large, the intersection area, so that, okay, now it looks better. So here I have 2, 4 and 3, 5, 1 is common, so I have to write it in the middle. 1, 3 and 5, and whereas here make a better diagram I feel, because this looks clumsy. Once again, okay, let's go. This is set A. This is set B. With yellow I will write which is common to both. 1, 3 and 5 is common to both. And here I have rest is 7 and 9. Here is 2 and 4. Okay, so if we represent two sets with two different colors, then the common area will consist the elements which belongs to the intersection of that two particular sets. Okay, so if I don't know any particular example, then or if I want to just the definition, if I want to represent using Venn diagram, then I can do it as this is one circle. Now I will fill it like this. This is another set. We'll fill this using horizontal lines. So now this particular portion, if you see, if I highlight it, contains horizontal lines as well as vertical lines. So this is the common area for both the sets. That means those particular elements will be in this set also and in that set also. So if this is set A and this is set B, then this particular common area will be A intersection B. Alright, so now let's discuss the next operation or next topic, subtopic as such. The next topic is disjoint sets. If you notice, we just discussed intersection of two different sets, but we may come through a situation where we don't find any elements common in both the sets, right? That means there is not a single element which is common to A and B. Then those type of sets we call it as disjoint sets. That means if I have set A and set B are called disjoint when A intersection B is a null set. Or how do we represent? We can use curly braces, just empty curly braces. That means there is no single element in A intersection B. That means there are no common elements in A and B. So if we represent it diagrammatically using a Venn diagram, now this is set A and set B. These two circles won't intersect if they are disjoint sets. They will be independent, two different circles, and they won't have any intersection area. They won't intersect, just like how two lines intersect like this. It won't happen. There will be two separate circles, disjoint circles, okay, of disjoint sets. So when intersection is a null set or we don't have any common elements in both the sets, then we call those sets to be disjoint. And in Venn diagram, they will be two different circles without coinciding, without overlapping or coinciding, even in small portion or a larger portion. Okay. So this is these are a term used to call the sets with intersection null set is disjoint sets. So if we want to define it, we can say that if let A and B be two sets and there is no single element common to A and B, then A and B are called disjoint sets. You will write down the definition once. Let A and B be two sets. Then if there is not a single element common to A and B, then we call A and B to be disjoint sets. Okay, let's take an example. Consider set A of even numbers between 0 to 10. Okay, so I can write 0, 2, 4, 6, 8 and 10, and B will be set of odd numbers between 0 and 10, so it will be 1, 3, 5, 7 and 9. Alright, so now if you see here, A intersection B is no common element throughout, so we can write it as a null set. So here A and B are disjoint sets, and using Venn diagram, A will contain 0, 2, 4, 6, 8 and 10, and B will contain 1, 3, 5, 7 and 9. So this is A and this is B. No intersection. Two different circles. Okay. Now what is the next topic? Let's get into the... Okay, before discussing the next topic, there are a few properties of intersection of sets that we should discuss. The first such property is A union B is same as, A intersection B is same as B intersection A. A intersection B means elements common to A as well as B. So same is a definition for B intersection A as well. Elements common to B and A. So both should match. Next is, if A is subset of B, then what will be the intersection B? A is a subset of B means, by definition of subset, every element in A will be in B. So which will be the common elements in A and B? Obviously all the elements in A are common to A as well as B, since A is a subset of B. A is a small part of a B. So common elements from both will be the whole set A. So A intersection B is same as A. The third property is A intersection B is equal to B. Suppose intersection of two sets is same as one of the set. That means the elements common to A and B is the whole set B. That means all elements in B are common to B. Obviously all elements in A are in B. All elements in B are in B. But all elements in B are also in A. That means B is a subset of A. Then A intersection B is a subset of A and A intersection B is a subset of B. Intersection means we have picking those elements which are common to A and B. That means which are there in A also and which are there in B also. So that particular set will be a subset of A, because all these elements will be in A. Similarly, all the elements here should be in B by definition of intersection. Okay. Next is A intersection A complement is a null set. Now we already discussed in the definition of complement of a set that we cannot find any common element in A and A complement. If we cannot find any common element, then they are disjoint sets. That means their intersection is a null set. No single common element in both the sets, that is A and A complement. Because by definition of complement of a set, we pick only those elements which are not in A and they are in U. So it is not in A means nothing in common in both these sets. So the intersection should be a null set. Then A intersection A is A, because we are taking intersection of a set with itself, then whole set should come because everything is common. Okay. Then A intersection null set. So with the set which or the elements which is common to A and a null set will be again a null set, because in null set there is no element. So obviously intersection should be again a null set. So these are 6 properties or 7 properties that we should note just after knowing the definition of intersection of sets and disjoint sets. Okay. So that's it. So now let's discuss the next topic, that is the union of sets. Okay. Union of particularly 2 sets, because now you have to learn just of 2 sets, and in further actually in future you will learn union of more than or union or intersection of more than 2 sets. Okay, so for the base we need to just consider 2 sets and their union. Okay, so let A and B be 2 sets. That is the starting. Okay, then the set of all elements of set A and B is called union of it. Okay, so the set of all elements of A and B of A and B is called union of A and B. Okay, so using rule method or rule form I can write it as A union B is same as the set of all such x such that my x is in A or x is in B. Okay, so when we were discussing the definition of intersection, we were forming a set of x such that x is in A and x is in B. So we want x to be in both the sets. Here A union B means we are just writing down all the elements together of set A as well as B. So the elements in it should either be in A or in B. It is not necessary that it should be in both. Only one. Even if it is in A, then it is in union, or it is in B, then it is in union. Okay. So this is the key word in the definition. When we have intersection, we want and. That means x should be in A and x should be in B. Here or condition is there. If x is in just one set, still it is in union of A and B. So this is how we denote. Okay. Now so in this write this A union B is set of x such that x belongs to A or x belongs to B. Let's consider an example. A is equal to 1, 2, 3, 4, 5 and B is equal to, I am taking the same example which I took for intersection, 1, 3, 5, 7 and 9. Okay, now we have to form A union B. So A union B means I have to just write both these elements together. So I have 1, and one condition is that we already know that whenever we list elements of a set, we cannot repeat any elements. So here too we have to follow that simple rule that we cannot repeat any elements. So particularly if we have some elements repeating, some elements common to A and B, then we will find that while listing we will come across it twice. So that time we have to avoid writing it again. So first I will write elements of A, and then first I will write elements of A, and then I have to write elements of B. So 1 I have already written, so I won't repeat it here. 3 also I have already written, so no need of repeating. 5 also already written. 7 is not written, so 7 I have to write, and 9. Now this is the union of A and B, A union B. That means I have to list elements in both the sets all together to form a set, and that will be union. And I have to follow a simple rule that I cannot repeat any elements. So I have to avoid writing the intersection elements twice. Okay. So if I represent it using a Venn diagram, so suppose I write colored circle is A and blue colored circle is B. Okay. So this is A, this is B. So A has 2 and 4 outside, and B has 7 and 9 outside, and other things are in the intersection area. So it is 1, 3 and 5. Okay. So we have to write these elements. We have to just write all the elements once and form a set. So that is A union B. No repetition of any element is allowed. Okay. Clear? Now let's move on to the next topic. Okay. Now we will discuss few properties of union of sets. Okay. Now first such property is A union B is same as B union A. So this is very much clear, right? If we take two sets, A is 1, 2 and B is 3, suppose singleton set, then A union B is 1, 2 and 3. If I write B union A, it is 3, 1, 2. Since order of elements or in whichever order we write is not important, so these two sets are equal because all elements here are also here. So A union B is same as B union A. So this thing is verified. Okay, this is true for any two sets. Even if intersection is non-empty, still we will get union to be same because we avoid writing the intersection elements twice, so there won't be any as such issue. So A union B is same as B union A. Now second property is if A is subset of B, then A is subset of B, then A union B is same as B. Take an example. Suppose A is singleton set 3 and B is 1, 2 and 3. Okay. Now here A is subset of B because element in A, every element in A is in B. There is only one element, that is 3. 3 is in B also. So A is subset of B. So let's write A union B. Union B is I have to write all the elements once. So I will write 3, 1, 2. Since 3 is I have already written, this 3 I don't need to repeat it. So now this set is same as B because every element in B is in A union B and every element in A union B is in B. So by definition of equal sets, we have B is same as A union B. So A is a subset of B means every element in E is a part of B. So whenever we write union, we will end up with the B itself. Okay, no other elements will be added to it. So A union B is same as B if A is subset of B. Let's see the Next property. A is subset of A union B and B is subset of A union B. Okay. A is suppose 1, 2 and B is 1, 3, 5. Then A union B will contain all elements in A and all elements in B also. Okay, so 1, 2, 3, 5. So if you notice, A is subset of A union B because every element in A is in A union B, and B is also subset of A union B because every element B in B is also in A union B. So this just simply by the definition. We're just writing down the elements in both the sets together. So it should contain every element in those sets. It should contain means the union should contain. So union will contain the set A also and set B also. Okay. Now let's see what is the next. The fourth property is we have A union of A complement will form the universal set. Okay, so suppose we have, we'll take an example. Universal set is equal to 1, 2 and 3. If I take A is equal to 3, then what will be A complement? A complement will be set of all elements in U that are not in A. So in A 3 is there, so rest elements is 1, 2. Okay, so if I form union of A and A complement, then what will be the outcome? 3, 1 and 2. So this will cover the whole universal set and this is same as U. So U is same as union of A and its complement. That is A union A complement is same as its universal set. Similarly, if I replace, not replacing as such, if I write A union A, now if I am taking union of the same set, then again I will end up with A. So just writing union, taking union means I have to just write elements in both the sets all together and without repetition of elements. So if I take union of A itself with it, a union of A with itself, then I will end up with A. And the sixth property says, if I take union of any set with null set, again I will end up with A. Now since null set is not having any element, in union I have to just write the elements of A, and in null set nothing is there. So again I will end up with the set A itself. Okay, so these are some 6 properties that we are supposed to know, and these are just simple outcomes of the definition. Okay, now let's discuss. Okay, the next topic is number of elements in a set. That means the total number of elements in a set. Now consider set A. 1, 3, 5, 7, 9. So here what is the number of elements in this set? Okay, now we will denote it using this n of A. Now small n of A means number of elements in set A is equal to 1, 2, 3, 4, 5. So n of A is 5. So this is a notation that we will use to say the number of elements, to denote number of elements of a particular set, and then we write just the number. Okay, so this is how we denote the number of elements of a set, that is n of A. Okay, so now we will discuss something more about it, and we will try to find the relation of number of elements in union of 2 sets with the number of elements in individual sets and intersection. What is such relation? Or we will try to develop a formula to find it. So my aim is, let's take that. Okay, now I'm telling n of A. I have 2 sets A and B. I'm telling n of A is 5. There are 5 elements in it, and n of B is 2. Now I will write the set also so that there is no confusion. 1, 2, 3. That is the first 5 natural numbers. And B, I am telling it as 2 and 4. Then what will be A union B? It will be 1, 2, 3, 4, 5. This is by the property. We can say this by the property of unions of sets, that if B is subset of A, then A union B should be whole of A. So we cannot repeat this 2 and 4 again because we have already included it here. Okay. So this is same as A. So N of A union B is 5. Whereas if we think A union B is set of all elements in A and B, so this should have been equal to N of B plus N of A, or N of A plus N of B. But why is that not true? Because N of A plus N of B in this case is 7, whereas N of A union B is just 5. So what is missing over here? That means just by adding the number of elements in two particular sets, I am not getting the number of elements that is in the union, though union contains elements from A and B. A and B means elements in A and elements in B, we write it together to form the union. But this particular thing is not equal. Why is that so? This is happening because when I am adding N of A and N of B, I am counting the common elements, that is the common elements in A and B twice. The elements in A, whereas in union, we don't repeat any elements. So if there are common elements for A and B, we will write it to be once. We cannot repeat it. So whereas in this, I am adding these 5 elements plus these 2 elements. Not adding the elements, I am counting it. So I am counting this 2 and 4 with A as well as B when I am adding this. So whereas I have to count it only once when I am talking about A union B. So to make this formula correct, I have to introduce something as A intersection B. So if I subtract the number of common elements from N of A plus N of B, then I will arrive at N of A union B. Let's cross check. Now what is A intersection B? In this particular example, A intersection B is 2, 4. That is, it is same as B. So N of A intersection B is equal to, this is 5, is 2. And N of A intersection B is same as N of B because B is subset of A, and by property of intersection of sets we have B is subset of A, then A intersection B is same as B. So it is 2, 4. So again we have again. So 2 minus 2 is 0. It is same as 5. So now we have arrived at the correct answer. So when we just add the number of elements in two sets, I am adding the common elements, or I am counting the common elements twice. So since I am counting it twice, I subtract the number of common elements once, so that I arrive at number of elements in the set A union B. So this is a formula. This is a very important formula actually. Even in further studies, we will use this particular formula in many places. So this is a very important formula. N of A union B, that is number of elements in union of two sets, is same as number of elements in one set plus number of elements in the other set minus number of elements in the intersection of that two sets. Now one more observation we should have from here is, now if I have a set not common, if I say 6, so not 6, again I will try to keep the number of elements same, 6, 7. In union I have to add 6 and 7. So N of A union B is 7. So again we will try to write this. N of A union B is same as things. N of A is 5 plus N of B is 2 minus N of A intersection B. In A intersection, if we take intersection of these two sets, these are disjoint sets. That means their intersection is a null set. So the number of elements in a null set is 0. No elements, right? So number of elements should be 0. So here we end up with 7. That is N of A. So here also we have verified. So one thing is that when we have A intersection B to be a null set, or if we know that A and B are disjoint sets, then N of A union B is same as N of A plus N of B minus 0. That means N of A union B is equal to addition of number of elements in both the sets. When is this true? When we have A intersection B is a null set. When we have A and B are disjoint sets, we just need to add the elements in A and B to get the number of elements in A union B. Whereas when we have some element in the intersection, we need to subtract it once. Okay? So this is an important observation when we are talking about number of elements in a set, in union of two sets, in intersection of two sets. Okay? Now we will learn few things. What we say now, we will use those things which we learned in this video to solve the practice at 1.4, and I'm sure that after solving many questions we will have a very good and very clear idea of all these things. Okay, and before practice at 1.4, we will discuss few word problems based on sets, and they are very interesting and they are just like a real life problem. Okay, so I think in practice set also there are few questions which are really interesting. So I end my video here. I hope that you understood the concepts of different operations that we can perform on a set or on two different sets, and this particular formula also. Okay, so please do write in the comment section if you have any doubts regarding any topic that I covered in the videos, and please watch my previous videos to know what is a subset or complement of a set, or if you have any doubt regarding the topics before it, please watch my previous videos and stay tuned for my next video to have a good understanding of what we discussed today or discussed in this video. Okay, thank you. Stay tuned.